Okay, guys, so now let's look at how we would do a t-test in Excel. Okay, so first off, when would we use a t-test? Well, it's when we don't know the population standard deviation. Sigma is unknown. Everybody see that? Okay. Last time we did, remember, it was 10 minutes. This time we don't know what it is. So we have the same data here and the same setup. What was the setup? It was a manager of a regional airport thinks that people are staying longer in the short-term parking lot than what he believes the average is, which is 40 minutes. So he goes outside, does a quick sample of 12 cars, yeah, gets these numbers, all right? And so he wants to use these numbers to determine whether 40 is a um, viable mean or not, whether that could possibly be the mean in this situation, mean number of minutes that people are staying in the short-term parking lot or not. Um, okay. And he wants to be pretty sure about it, doesn't he? Okay, so we'll get to that in just a minute. Another, like I said, this is the same data we just had for the z-score problem, right? But I wanted to put the formula on here because there's something I want to show you. And we're going to have a different table up here, different numbers here, because we're not using our z table anymore, are we? We're doing a t-test now, aren't we? So it's a little bit different. Okay, so first off, though, what's not different is how we're going to get to it in Excel, to the actual test in Excel. Okay, so please look back at the other video if you don't have the data analysis package installed. If you do, go to Data, and go over here to data analysis. If you do not have this, an analysis group and the data analysis pack installed, please look back at the z-score video, the first video for chapter 10 to see how to do that, or in the lecture videos. I do it multiple times in the lecture videos. Okay. All right, so let's go to data analysis. All right, and let's go to t-test, paired two sample, t-test paired two sample for means. Okay. All right, so click OK or double click it. And I've already done it. Let me empty this real quick so we can redo it together. Come on. All right. Uh, and this. Okay, so it's going to look like this. Yours is empty, right? I just don't want to start the video over. So, all right. It's going to look like this. Now we want to input the first variable range, which is the minutes, don't we? Okay. So let's go ahead and do that. And those are the minutes we found from our sample. Now, variable to range, I have this dummy column here, don't I? Why do I do that? Because Excel's going to make me enter something, because this is a paired two sample test for means. Excel does not have a, excuse me, one sample test for means. All right, so we're going to have to come up with some, because Excel's not going to let us leave this empty. All right, so we're going to come up with this dummy variable. We'll just insert zeros. For the t-test, I believe it has to be the same length as the two columns have to be the same length, okay? But I'm not sure about that. I'm not sure if we'll carry the zero straight down or not. But anyway, just go ahead and fill out the zeros here for the dummy column. All right, hypothesize mean difference. So what is our hypothetical mean, or what is really what we believe is the mean? So again, we have the same setup, HO-HA or HO, H1 or HA. Remember, it's the same thing. I always seen it as HA, but our book uses H1, so let's use H1. All right, so hypothesized mean is 40. Okay, did we include our labels in our setup? Yes, we did, in our A1 and B1 here. What is our alpha 0.05? That is the standard. In fact, that was probably already filled in for you in Excel, because it's just the commonly used alpha. You want to be 95% sure, right? That's good enough for most scientific work, and it's good enough for most business, other than, say, manufacturing, where there you want to get to the Six Sigma, don't you? But anyway, for our alpha for testing this, we want a 0.05, okay? And our output range, let's go ahead and put it back in N3 where we had it last time. Okay, so pretty similar setup to the last problem. Remember, you can put in a new worksheet or a whole new workbook. But anyway, pretty similar to the setup last time. And let's go ahead and click OK. But our output looks a little bit different. So let's slice and dice this. Okay, so this is our answer. This is what we've gotten, isn't it? Okay, so let's change a couple things on here. First off, let's take out this dummy column. We don't need that. Remember, we just put that in there so Excel would function properly. 2 sample. Well, this is a t-test of a 1 sample mean. Okay. And what else can we bring out of here? Well, we don't have a correlation, and why is that? Because we didn't really correlate 2 variables. We'll get to correlation in chapter 13. That'll be on the next video. But let's go ahead and shift the cells up. Delete those and shift the cells up to get rid of that. And I think, well, we can take out this. It's not the mean difference. This is our hypothesized mean. Okay, so let's look at what we have now. All right, so we have a mean of 48. Okay, same mean we had last time. A variance of 96.7, pretty close to our 100 variance of last time. Observations, we have 12. Hypothetical mean, we have 40. But what's this right here? Observations, we have 12. DF, what is that? We need it for our table. Remember, degrees of freedom. How do we get degrees of freedom? It's our what? Who remembers? Sample size minus 1. Remember, you only have 1 degree of freedom because, or you only have one of those variables in your sample size is free because 11 of them, if 11 of them are predetermined or free, then that last one has to be predetermined, doesn't it? Okay, don't worry about that. Just remember 12 minus 1. Okay, here's our actual answer for the t-stat for our formula right here. Okay, which is what? 2.81. And what we want to see is if that 2.81 falls to the right of our critical value, whatever it may be. Remember, we were getting it from the table before, but now it's going to give it to us over here. But we'll look at it in a second. Whether that 2.81 is to the right or left, if it's of our critical value that we got from the table, that Excel got from the table for us. So if it falls in here, we're going to reject the null hypothesis. We're going to say, actually, it is greater than 40. If it falls over in here in the 95% of the area, which is 1 minus our alpha, then we're going to say what? We can't reject that null hypothesis. We didn't prove the null hypothesis, but given this setup, we cannot reject the null hypothesis, okay? All right, so our t-stat is so how are we going to know if this t-stat falls over here or not? Well, let's look for our critical value right here. T, critical value, 1 tail or 2 tail? We want 1 tail, don't we? Because this does not say not equal to. This gives us direction, doesn't it? It says less than or equal to or greater than for our alternate hypothesis. Okay, so we're not splitting this into 2, are we? It's only on one side. This one down here is 0.01. If you notice, that 0.01 is a lot smaller than the 0.05, isn't it? Makes sense. This is 5% of the area under the curve. This is 1% of the area under the curve. Okay, but anyway, we're using this one, aren't we? So right here, since this is a one-tailed test, I see that my t critical value is 1.79, 1.80, 1.795. Okay, so if this is 1.795 and my t-stat is 2.81, where does 2.81 fall in relation to 1.795? It falls out in our rejection zone, doesn't it? Okay, so that means we are going to reject the null hypothesis. We're going to say there's a 90, at least, just looking at it, we can do the math by figuring out our p-value, our true p-value over here, which is done for us. But anyway, in fact, let's do that. We can say that with a one-tailed test, there's only a 0.8%, 0.008 chance, 0.8% chance that this mean from these variables, that we would have found this mean if our actual mean is 40 as we believed. That's a very small percentage, isn't it? 0.8%, 0.008. It's way smaller than 0.05, isn't it? And it lines up. That 0.08 is right here with the same value as our 2.817 t-stat, right? Remember, we have different worlds down here, don't we? You can represent it in different ways. Okay, so we can look at our critical our alpha versus our excuse me, our p-value, or we can look at uh, our critical value t-stat versus our actual t-stat that we figured. Okay. All right. So as you can tell, we are going to reject the null hypothesis, and we're going to accept that people are staying in this lot for more than 40 minutes. Now, remember, this is a big decision, isn't it? So that means he can justify going to the city or the county or whoever's handling this airport and saying, or the state or whoever, maybe even the federal government, and say, hey, we need more money to build this parking lot because people are waiting longer than what is acceptable by our standards or whatever, written into law or whatever it may be. Okay, now let's look at the standard error just really quickly. What is the standard error? It's our standard deviation over our sample standard deviation over the square root of sample size. Okay, all of this data, and it's just the denominator of this formula, isn't it? All of this data is in here, isn't it? Okay, our observations, our sample size is in here. Actually, it's not in here, but we'll get our actual standard deviation. But we'll get to that in the next chapter when I show you guys. I'm going to show you how to run, what am I trying to say here? Run regressions in Excel. Okay, so I think that's all I wanted to show you for this this part of Excel. If you have any questions, you know where to get a hold of me. And next, this is going to be it for the Excel for Chapter 10. And next, we'll be looking at Excel for Chapter 13. All right, very good.